Hi, my name is Mani Ali Khani. I am Dean and Professor of Orthodontics at CTOR Academy, and I'd like to welcome you to another session of CTOR channel. The subject of today's discussion is asymmetrical V-band. In last session, we described what happened if we put a central V-band in equal distance from two adjacent brackets, and we analyze the system to learn that only two moments opposite of each other equal in magnitude appear in our system. Today we're going to concentrate on asymmetrical V-band in rigid wires. Assume we put a V-band closer to one bracket and farther from the other bracket. What forces and moments appear in our system? To answer these questions, first let's look at the moment. Similar to the central V-band example that we discussed last time, assume we have two wires that passively placed in two adjacent brackets, and we are standing this time closer to one bracket and farther from the other bracket. If I'm grabbing these two ends of the wire and I bring it up in equal height, what will happen to the adjacent bracket? Of course, you're expecting the shorter wire will produce higher angle of activation, therefore larger magnitude of the couple, therefore larger moment. On the other hand, the wire that is longer and farther from the bracket would have a lower angle of activation, lower couple, and therefore lower moment. So if you are putting asymmetrical V-band, you're expecting one side to receive a larger moment, the other side to receive a smaller moment. And of course, the moment are opposite in direction. How about forces? To analyze the forces in our system, let's divide the two-couple system to two one-couple system. Assume we have a premolar and a canine, and first we put a bracket on the premolar and a button of the canine. If we establish a one-couple system from the premolar, what are you expecting to see? If we're bringing the wire up to engage on the button of the canines, an extrusion force appears on the canine. An intrusion force appears on the premolar, and a moment counterclockwise appears on the premolar. This is the one-couple system that we studied previously. Now, what happens if we do not change the position of the V-band and run exactly the same design of one-couple system, with this difference that this time we put a bracket on the canine and a button of the premolar? If you remember from one-couple system session, we discussed that as we move the V-band farther away from the bracket, the magnitude of the forces and the moment decreases. In this case, because the V-band is farther from the canine, you're expecting lower forces and lower moments. Now, if we combine these two systems together, you can see the total forces and moment that appear in your system. There would be an extrusion force on the canine, intrusion force on the premolar, and counterclockwise moment on the premolar that is larger than the clockwise moments that appear on the canine. But there is one problem here. This system doesn't seem is in equilibrium. The forces cancel each other, but the magnitude of the moment in the system, they are not equal. Therefore, the system shouldn't be in equilibrium. Well, actually it is. If you look precisely, you will notice that the forces that act on the canine and the premolar that apply on two sides of the wire, they're actually producing a couple. And the magnitude of the moment of that couple is the missing moments that we have in the system to have equilibrium. In another word, the moment that produced by the forces is clockwise, same direction, and the small moment that applies on the canine, and with the moment on the canine together, they cancel the moment on the premolar. Of course, in this discussion, I'm showing the forces and the moment that is applied on the tooth. But in reality, this equilibrium should be measured at the level of the wire, not at the level of the teeth. To summarize what we learned today, anytime that you have an asymmetrical V-band, always draw in both sides of your V-band two moments toward inside or the mouth of the V-band. For the side that is closer to the V-band, draw a larger moment. For the size that is farther from the V-band, draw a smaller moment. Now, draw your forces. In these examples, we are having vertical forces. Draw your vertical forces, so produce a couple or a moment that is in the same direction as the small moment in your system, that is the canine. So with this trick, quickly in the clinic, you can know what extrusion forces, intrusion forces, or moments clockwise or counterclockwise appear in your system on two adjacent teeth that you put an asymmetrical V-band in rigid wire. Thank you for listening to another session of CTOR channel. I hope you enjoyed the session. In next session, we will discuss asymmetrical V-band in flexible wire. If you have not subscribed to our channel, please go ahead and subscribe. And please press the like button. Thank you.